Assalamualaikum and hi, my name is Kuzaima Rabia binti Muhammad Karunizar. My metric number is TE190155. Our project title is Detecting COVID-19 using Deep Learning Method. For the introduction, the problem statement that we face during this study is COVID-19 has no specific treatment except vaccines to help protect the body. Therefore, a proper preparation is needed in order to prevent the virus from spreading. Secondly, imaging physicians and doctors are burdened by the inflow of patients' cases in a short amount of time. Because of COVID-19 cases are increasing day by day, there are tons of medical images of patients until the healthcare workers is hard to manage all of them. By studying this issue, the project that we have done is aimed to help virologists and radiologists to make a more accurate and quick diagnosis in the fight against COVID-19. Additionally, the purpose of this project is to enhance the use of deep learning methods using MATLAB for COVID-19 detection as an early diagnostic. The more earlier someone gets diagnosed, the more earlier they can get quarantined. Thus, it can lead to the decreasing of COVID-19 spreading. Other than that, more patients will get treated and monitored by the professional healthcare workers, and eventually, deadly cases regarding COVID-19 will be reduced. The image that has been frequently choose from the previous studies are X-ray and CT scan image of lung, and the technique used is deep learning method, as it can improve categorization and increase the accuracy rate of the result. However, in our scope of study, we are focusing on X-ray images of normal lung and infected lung by using deep learning method in MATLAB. It is to meet the goal of recognizing of COVID-19 virus earlier without burdening the staff. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and good day to doctor. My name is Kalisa Betty Johari, matrix number CE190091. So I'm going to present the methodology for our project. As we can see in this slide, this block diagram is the workflow for our project, which is the detection of COVID-19 using the deep learning method. So for the first block is create image data store. First, an image data store was created, and these images were saved into different subfolders by class name. In COVID subfolders, infected X-ray images will be saved, and in normal subfolder, uninfected X-ray images will be saved. So next is split data for training and validation. So the data were split for training and testing. To get the accuracy, testing is important. So the next block is design layers. So next, ResNet 50 network was modified according to our data, because in ResNet 50, millions of images are trained with thousands of classes, and in our case, we have 20 images with 2 classes. So next is define other parameters for training. So defining other parameters, for example, is initial learning rate, maximum number of epochs, batch size, and etc. So the next block will be train model. The model was trained and hyperparameters were optimized if it was required. So the next block will be test model. When the model was trained, the dataset of the model was tested to check its accuracy. So the last block will be deploy model. When everything works fine, the model can be deployed further on a hardware for real-time application. So the next part for methodology will be the flowchart. This flowchart as we can see in the slide, this is the flowchart of COVID-19 or normal X-ray images in MATLAB. So first, an image database was created and the images to be evaluated were saved into different categories, which were COVID-19 infected images and normal healthy images. And next, the data will then be split and tested to improve accuracy, as I have mentioned in the diagram workflow. Next, the MATLAB syntax will then count sample images for every classes. 20 images have been used with 10 infected COVID-19 images and 10 healthy normal images. After that, it will visualize some images to see how the images differ from each other for each class. Furthermore, the MATLAB will count the number of categories, and in this case, the number of categories were 2, which were normal and COVID-19 infected categories. Data augmentation was processed in MATLAB since an image data augmenter configures multiple pre-processing options for image augmentation, such as resizing, rotation, and reflection. Data augmentation was implemented to have better image classification. The image was then read from the database and classified. So lastly, the COVID-19 images were extracted from the downloaded X-ray images.
Assalamualaikum warahmatullahi wabarakatuh, and very good evening to our lecturer and fellow friends. My name is Muhammad Ibrahim, DE19048, and I will be presenting for the simulation part for my team. I cannot open my video is because my camera is kind of broken. My laptop is malfunction for last week. So without any delay, I will proceed with the coding. For our coding, the first step is we use the IMDS, where this coding we will store the data image on a folder, and it will automatically detect its subfolder and it will label and include its folder name. And then we will use the all sample equal to count each label IMDS, and we will numbering of each number, and we use the numbering underscore image length and visualize random number. We use the coding of perm equal to random perm, and number of image that it will emit is 9 image. As you can see on our right, that is our first output that we have shown, that normal, and COVID, then normal, COVID, normal. For our sample, we take 20 of the X-ray image from the internet, and then we insert inside our MATLAB. Then we will recognize which one of the image got COVID or which one of the image got non-COVID, and proceed with the coding. Sorry, we start with the figure for IDX equal to 1 length perm, and subplot it to 3 for the row and column. It will show it read IMDS file perm, and the title will also available there. And we end our first coding. Then we will proceed with the new coding IMDS train, IMDS test, where this will separate the image. When this step is over, it will show that when we select an image and we insert the image, we will get an output that will show that if the person got COVID or not COVID. So I proceed with the coding. We use the num class for num and categorize it. We use the IMDS train, read FCN, and IMDS test, read FCN. We use the option here, and we proceed with the layering part, where the image will be read, then the COVID will be more transparent for doctor to detect it. Then we use 5 layer of convolution. The convolution here we use 8 bit, 16 byte, 32 bit, 64 bit, and 128 bit. Then we end our layering with softmax layer, classification layer, and then we start with data argumentation, where in the data argumentation it is the operation of rotation, reflection, and shear on x and y. And then we store our augmented data in the AUMDS augmented image data store. Image train data augmentation. Then we proceed with the next transfer, where next transfer is equal to train network. Then we use the load theory model .map. We use the augmented test image, where the augmented image data is stored here. Then we use predict and label to classify the image, and then we use some operation here, and then we proceed with the actual label. Actual label is equal to IMDS train dot label. Then we proceed with the confusion metric, where in the confusion metric we will plot a graph. We start with a figure plot confusion, actual label, and predictor label, and we use title. We use as the title is confusion metric ResNet 15. Then we proceed with the IMAP for the pre-processing image resize, IMAP, and image activation. Then finally we use the layering process equal to convolution 1, where channel 1 is equal to 8 is 1/8, and I equal to the image. Use net transfer, layer, and channel. Use pyramid label, verbose, and figure. So right here, this is the image folder that we have chosen to emit in the MATLAB software just now. So the idea for this project is basically that we will choose one of this image and insert it inside the MATLAB coding. Then the coding will be processing the output. When the output show, it will show that this image has been through the image processing analyzed through deep learning method, and it will show if the patient got COVID or non-COVID. So that's all from me. Without any delay, I will proceed to my other team member. That's all. Thank you very much.
So next I'm going to present the conclusion for this project. So early detection and diagnosis of COVID-19 using deep learning procedures with the least amount of costs and complications are the most important stages in preventing the disease and pandemic progression. With the integration of deep learning algorithms into the equipment of radiology centers, it will be feasible to diagnose this condition faster, cheaper, and safer in the near future. The use of these strategies in COVID-19 quick diagnostic decision making can be a valuable tool for radiologists in reducing human error and assisting them in making choices in critical situations at the peak of the disease. This study backs up the premise that deep learning algorithms are a promising technique to improve healthcare and diagnostic results. That's all from me. Thank you.